All right, subscribers, welcome back to another episode of Science with Surbeck. Today what we're going to be talking about is section 2.4, which deals with representing data. Now, before we get into the details of these notes, there are a couple of objectives that I have for you, and you should be able to complete by the end of this video. Objective number 1, create graphs to reveal patterns in data, and objective number 2, interpret graphs. So we start out here with the definition of a graph, and a graph is defined as a visual display of data that makes trends easier to see than in a table. Now in science we have 3 common types of graphs. One of which is a circle graph, or commonly known as a pie chart. Another graph is a bar graph. And then a third type of graph is a line graph. We'll go over more details on each of these types of graphs in the notes to come. Now, the types of graphs will be determined by each individual set of data. Okay, so let's get into details about the first graph here, the circle graph. So the circle graph is defined as a graph that uses wedges to visually represent percentage of a fixed whole. These parts of the wedges are labeled as percents. And the circle as a whole represents 100%. And a circle graph can also be called a pie chart. Okay, so a pie chart or a circle graph would look like this. And so I want to ask a few questions from this chart here. The first question I want to ask is what percent of chlorine sources are natural, shown from this graph? Okay, so in this pie chart, and I know it's difficult to see because it's a black and white photo, but we have a dark gray and we have a light gray. Now the dark gray sources says manufactured compounds. That means they're not natural. And then this light gray says they come from natural sources. Okay, so there are 2 spots in the pie chart here that say they're from natural sources. Okay, so we have here 15% from the methyl chloride, plus the 3% from the hydrogen chloride. And that gives us a total, if we add up 15 and 3 together, that gives us a total of 18%. So that would be our answer to this question here. Now my next question is, what percent are manufactured compounds, or what percent of chlorine are from manufactured compounds? Okay, so manufactured compounds, again, is this dark gray portion. So we have 10% plus 3% plus 6 plus 28 plus 23 plus 12%. Now, I'm not going to write all that out because I'm running out of space, but if I grab a calculator here, and again, I just add these together, I have 10% plus 3% plus another 6%, 28 plus 23, and plus 12. I get a total of 82%. Now that's good because if you add together 82% and 18%, that gets a total of 100%. Now our last question here is, which source of our chart here, or what source provides the most chlorine to the stratosphere? And so to find this answer to the question here, again, the most source or the largest source, what we're doing is we're looking for the largest chunk on this pie chart. So if we look really closely, we'll find that our CFCs, or our chlorofluorocarbons, produce 28% of this contribution of chlorine to the atmosphere. Now that's chlorofluorocarbon 12 that produces 28%. So the answer to this is CFC12 because it produces that largest percent. Again, pie charts are really useful if you're showing parts of a whole. You're wanting to see what is a compound produced of, what is a certain percentage of things in something like the atmosphere. It's really good for seeing parts of the whole. All right, so our other type of graph, our second of 3 types of graph, is known as a bar graph. So a bar graph is defined as a graph that shows a quantity varying across different categories. Now, in a bar graph, factors can include things like time, location, or temperature. Now, it's really important to recognize the organization of our bar graph. So we start out here with looking at the y-axis or the vertical axis. Now this y-axis is going to display the quantity being measured. Now this quantity being measured is known as the dependent variable. Now another important part to think about here at the bar graph is our x-axis or the horizontal axis. Now the x-axis is going to display the independent variable. Now bar graphs are very useful for comparing one thing to another. Now using this graph here, I want to ask you this question, and the question is this: during which 4 months does Jacksonville receive about half of its annual precipitation? Another way of stating this question is during which 4 months does Jacksonville receive the most precipitation? So if we take a look at the bar graph, we are going to be looking at a couple of things. One, we see it says average precipitation in inches, and then on the x-axis it says the months, and it lists them January through December. So we're looking for which bar has the highest amount or is the largest. So one that pops out right away is August. So one answer is August. Then we're looking for the second largest bar, and right next to it is September. And then we're looking again still for a higher bar. It will be a little bit shorter than these bars, and it looks like June is our next highest bar. And so we look for, again, the next highest bar right below June, and that is July. So these graphs make it really easy to identify certain questions and make it really easy to identify things that happen over a period of time here. Now again, this is useful for comparing, and we compared the average precipitation in the given month for the city of Jacksonville, Florida. All right, so now we can move to our last graph that we commonly use, and that is known as a line graph. So a line graph is defined as a graph that has points on a line that represent the intersection of data for 2 variables. And these line graphs are known as scatter plots. And again, it's important to recognize the organization of a line graph. And so we start out here with the y-axis or the vertical axis. And it is going to display the dependent variable. Now the dependent variable is that variable that deliberately changes during an experiment. Now the x-axis is on the horizontal axis, and it is going to display the independent variable. And remember, the independent variable is the variable determined during the experiment. Now, line graphs are the most commonly used graph in science. And the other thing that we need to talk about here is what we call the best fit line. And the best fit line here is this line drawn in these points, and the line for a best fit line must be drawn so that about as many points fall above the line as they do below the line. And what happens here is it is going through or dissecting as many of those points as possible. Now, the reason we get some points above and some points below is because points on the graph are scattered. Okay, because our line graphs are really important and they're the most commonly used types of graph in science, I want to go into a little bit more detail here about the line graph and what we can do or what we can know about a line graph. So we get to this point about interpreting a line graph, and we need to start with this term known as linear relationships. And these linear relationships are going to occur when a best fit line is straight. And this linear relationship directly relates to the variables of the graph. Now, another thing that's really important in our line graph is determining or looking at the slope of the line. And so a positive slope is going to occur if the line rises to the right. And so if we have a positive slope, it's going to indicate that the dependent variable increases as the independent variable also increases. Now, on the flip side, we can have a negative slope, which is going to occur if the line sinks to the right. And so if we have a negative slope on our line graph, it's going to indicate that the dependent variable decreases as the independent variable increases. Okay, so what we can also talk about here is calculating the slope in our line graph. And so to calculate the slope in our line graph, it's going to use the data points and calculate that slope. Now, the slope has a formula associated with it. And so that formula for the slope is the slope is equal to our second y point that we pick minus the first y point, all divided by the second x point and the first x point. Now, in science, we like to simplify that, and we have the triangle here that represents change in y over change in x. And again, the triangle represents change. So change of y over change of x. All right, so now what we can do here, we can kind of tie everything together in terms of our info, our business on graphs. So here we have our graph interpretation. Now, our graph interpretation is this. We need some tips to interpret graphs. So our first tip when we want to interpret a graph is identify the independent and dependent variables. Our second tip is look at the ranges of data. Our third tip is to determine what measurements were taken. Our fourth tip here is to determine if a graph is linear or nonlinear. And if it's linear, find the slope. And then our fifth tip here is use the terms interpolation and extrapolation as needed. And so it may be helpful here to define interpolation and extrapolation. So we start out here with interpolation. And interpolation is defined as the reading and estimating values falling between points on the graph. And our other term here is extrapolation. And it is defined as the estimating values outside the points of the extending line. Okay, so now we can kind of piece all this together and look at a graph and talk about some examples. So we have our example here, and we want to determine a couple of things from our graph. So the first thing that we want to identify is the independent and dependent variables. So remember, the independent variable is always going to be on our x-axis, and so the independent variable is our months. And our dependent variable is that y-axis, and that is total ozone measured in DU, or we call that Dobson units. So the ranges of data, remember we have two different variables here, but if we look at the dependent variable, we're going to look at our total ozone, and the ranges of data in our y-axis is from 0 all the way up to 400. And then we also have a unique thing happening here with our two lines. So notice here the top line says 1957 to 1972, and the bottom line here is from 1999 to 2000. So our year ranges are also something that we can incorporate into this data. So again, those are our third type of variable we take in here. Now, the measurements that were taken were the Dobson units of ozone measured at the point Haley. Okay, so our last question here is the graph linear or nonlinear? Well, to be linear, you have to have a completely straight line. So you see how this line or both lines actually curve up and down? Because of that, it is non-linear. Now, another thing that I've noticed here just by looking at the graph a little bit more is that the months of the year, they're not every single month of the year, but they're specifically from August to April. So yes, they are months of the year, but they are not every single one of those 12 months of the year. And then the last thing that I want to leave on here is that this graph here is identifying a significant trend in ozone levels, and it's verifying the depletion of ozone. All right, so that is everything here in section 2.4. That's actually everything in chapter 2. So we learned a lot about what we can do with data and some numbers here in science once we obtain them. There's been a lot of good information discussed in this video. I hope you have enjoyed it. And as always, if you haven't already, remember to subscribe.